So the way I understand this problem is that at noon, ship A is there, and ship B is here, and then start sailing. Ship A starts sailing this way,
Okay, yeah.
and ship B starts sailing this.
Okay, yeah.
Is that right? Okay. And so we're trying to find at what distance, at what rate this distance here is changing.
Yeah, exactly.
Okay. And this would be the rest of the triangle. Okay, got it. So for this, would we just use Pythagorean theorem? So derivative, so d over dt plus db over dt is equal to dc over dt, or squared. All of those terms squared. Sorry, but like, because that's what I'm kind of seeing is.
I think you're on the right track because
Yeah.
at any point after a noon, wherever they are is going to form some right triangle.
Yep. So what I'm kind of thinking is this: at 4 p.m., ship A has sailed 140 miles, I believe. Yeah, 140 miles, which means that this distance here, sorry, it's still 140 miles, which means that this distance here would be 10. And then ship B has sailed 100 kilometers. Ship B has sailed 100 kilometers, so this distance here is 100.
So again, for these related rate problems, the procedure is always the same. So what's always the first step in these problems?
Setting up our equation.
Yeah, you need to set up an equation that relates the variables together. You typically don't want to deal with these distances yet because those are specific values that get plugged in later on once you set up your equation.
Okay, got it.
So what's the
equation I've kind of been thinking of using is Pythagorean theorem, like a squared plus b squared equals c squared. So
okay, what's
x squared plus y squared equals d squared, I guess, the distance, capital D.
Okay, what does each part mean?
X would be the distance from A to the starting point of B.
Okay, yeah.
And Y is just how far B is sailed.
Okay, yeah.
And then our hypotenuse would be the distance.
Okay. All right. So now we have to figure out the equation. What's next?
We have to differentiate this equation.
Okay. What you got?
So 2x times dx dt plus 2y times dy dt equals to 2d times dt over dt.
Okay.
We know x, y, dx, dy, and dx, or dx dt and dy dt. We can also figure out d as well. So this should just be like just plugging it in and working through it.
Okay.
So at 4 o'clock, x is 10 and y is 100. Calculation. But my math is right. So it's 2 times 10 times 35 kilometers an hour plus 2 times 100 times 25 kilometers an hour times 2 times d. D would be square root of 1100, I believe.
Okay. 100 squared.
2 times the square root of 1100.
1, 2. Oh, it should be 100. What's 100 squared?
10,000, right? Or sorry, not 1100. 11,000. I'm sorry, 11,000.
It's well, what's 100 squared, and then what's 10 squared?
I'm sorry. 10,100. That's what I
Yeah,
meant to say.
10,100. Okay.
Times dt over dt. From there, you can just divide by the square root of, or by 2 times square root of 10,100. So you get,
So no, look at what's happening with the x value.
it's getting smaller.
Okay, so then how does that? What does that tell us about the rate of x then?
Is it negative?
Yeah, it's negative.
Okay. So then it would be, oh yeah, I see why now. I see why now. Okay, yeah. So it would be 550 in that case.
Oh, whoops! I
Negative.
forgot the 25 here.
Oh, okay, gotcha. So 10 times negative 5 is negative 350. Negative 700 times plus 5,000. Yeah, negative 700 plus 5,000. Which is 4,700 or 4,300.
Okay. Yeah.
Over 2 times the square root of 10,100, which is, and then that would be dt over
yeah,
dt.
that should be it then. Okay, so that makes sense.
Yeah, that does.
Can